everyone, it's Mrs. Griffin with the Unit 3 Lesson 13 video. We're going to continue talking about compositions, and then the rest of this lesson is practice of previously learned topics. So, for starters, if you can remember with a composition of transformations, that's where you do more than one at the same time, you're going to begin first by doing the innermost or rightmost, depending on how it's written out, and then continue and do the leftmost or outermost last. Okay, now when we do a transformation of any kind, what we end up with is a correspondence. That means that we have a pre-image that maps to an image. Parts of one figure are paired with parts of another. When we use our rigid motions that we've been discussing, then what happens is that's not only just a correspondence, it's also a congruence, because not only does each point map to another point, but all the distances between those points stay the same. So what we end up with is a figure and its image being the same size. Every congruence is a type of correspondence, but not vice versa, because we could do something to change the size, even though the corners or points would still match up with another point. It could be enlarged or shrunk, and so that wouldn't be a congruence, but it would still be a correspondence. Okay, so corresponding is the most important thing that we have to understand, and that's what maps to what. Now, the shortcuts. These are just short rules that'll help us to perform these transformations faster. So for starters, when we reflect over the x-axis, what we do is we negate the y value, and this is how you can do this without graphing it. Remember that negate means to change the sign. If you are reflecting in the y-axis, you negate the x value instead. Okay. If you're reflecting over the line y equals x, y equals positive x, then you switch your coordinates. So whatever was y becomes first, and whatever was x becomes second. And when we're reflecting in y equals negative x, we switch and negate them. So we change their signs and switch their places. Okay, now, reflection in the origin is the same thing as a rotation of 180. They are the same. And for both of them, you're going to negate both your x and y coordinate. It is important to note that for all three of these rotation problems, these are only shortcut rules that can be used when we're talking about the origin being the center of rotation. If you'll notice, the notations that I have here don't have a center of rotation listed. If there is no center of rotation written, the default is the origin. So just putting a degrees means you're using the origin as the center. Now, a rotation of positive 270 and negative 90 are the same. If you can remember the shortcut for this, what you'll do is you'll negate the x value and then switch them. And for a positive 90, which is the same as a negative 270, it's the other way around, you negate the y value and then you switch them. And then for translation, really you're just adding. So whatever your x value is, you're going to add the first part of your translation, the first number. And for the y value, you add the second part of your translation. Okay, so with all of these, first off, pause this and graph everything in the lesson and then come back to me. So for numbers 1 through 4, we're referring to this picture of an octagon. It's regular, meaning all sides and angles are congruent, and there are symmetry lines L and M intersecting at point P. So remember that when we do a composition, we work right to left. So that means that the first thing we're going to do to point G on number 1 is rotate it around point P 45 degrees. And then once we do that, we'll then reflect that over line L. So for starters, we do need to know how many degrees it is between each letter. So since the full circle is 360 and there are 8 letters that are equally distant apart, we're going to divide that. And that is 45 degrees. So it's 45 degrees between each letter. This is positive, so we're going to go counterclockwise. 1 letter, because 45 degrees between each letter. So starting at G, 45 degrees counterclockwise would land me on H. Then we're going to reflect that over L. Remember, that means you fold it directly over L, and it would then land on C. For number 2, again, we're working right to left. So first the reflection and then the rotation. Remember that when we have 2 letters, we do one at a time. So starting with E, we're going to reflect that over line L. Reflect it straight across line L, and it would land on F. And then we're going to do the same thing from point F, reflect that over line L, and it would land on E. And the order does matter here, so pay attention to that. Next, we're going to rotate each one of those around point P positive 225. So that's counterclockwise because it's positive. And if you take 225 and divide it by the 45 degrees that are between each letter, then you'll see that that's 5 letters. So counterclockwise, 5 letters. We're going to start with F and do F first. So F, 5 letters. 1, 2, 3, 4, 5, and it would land on C. Then we're going to go and do E next. So E is here, 1, 2, 3, 4, 5, and it would land on B. For number 3, first the reflection over M, then the reflection over L, and we're going to do A first, then B. So if we look at A, and we're going to reflect that over line M. Remember that when you're reflecting it over the line, you're going perpendicular to the line. So A over M would land on D. B over M would land on C. Then we're going to take each of those and reflect them over line L. So D across line L would land on G. C across line L would land on H. And then for number 4, first the rotation and then the reflection. So we're starting with point A. This is negative, so we're going clockwise, and it's only one letter because there's 45 degrees between each letter. So that would land on H. And then H reflected over line M, perpendicular straight across it, would land on E. So for the next ones, we are on the graphs, so you could use a shortcut or you could actually use the graphs. It's up to you how you remember it. So for number 5, we've got the point 1, 2. The first thing we're going to do is rotate it around the origin 90 degrees, and then we'll take that and reflect it over the x-axis. So if you remember the shortcut rule, you can use it. If not, you can turn your paper. Remember that if you are going positive 90, you're going to go counterclockwise, and you'll see that 1, 2 is now at negative 2, 1. And so then we can go back and put in negative 2, 1. And then if you were to reflect negative 2, 1 over the x-axis, it would become negative 2, negative 1. For number 6, first we're going to reflect that over x equals 2. Then we are going to rotate it 270. So if we do this over x equals 2 first, remember it's a vertical line. And we'd go 1, 2, 3, 1, 2, 3, and we would be here at the 0.53. Now to rotate that 270, you can use the rule, or you can go counterclockwise, 1, 2, 3, and this point is now at 3, negative 5. And so that would be our final answer here. For number 7, first we're going to reflect over y equals negative x, and then we're going to translate 0, 3. So y equals negative x, remember you're switching and negating. And then you're going to add for a translation. So 2 plus 0 is 2, negative 3 and negative 3 is negative 6. For number 8, first we're going to rotate it around the origin 90, then reflect it over the x-axis. So 90 degrees around the origin is positive, so we're going to go counterclockwise. And you'll see it's now at 0, negative 3. And so that would be here. And then if you were to reflect that over the x-axis, you'd be up here at 0, positive 3, which is negating the y. For number 9, first we're going to reflect it over the x-axis, then we're going to do a translation. So reflecting over the x-axis, we just mentioned, negates the y. And then translating it to 5, you're just adding, so 5, 6. For number 10, first we're going to reflect it over y equals x, then over the y-axis. So y equals x switches, and then the y-axis negates the x. All right, and then recall for any combination of rotations around the same, you would be doing a combination by adding them together. So that's the same as a rotation of negative 90. Orientation. That word means the direction a figure faces or is labeled. Orientation is not preserved under a line reflection because that's when you're going to get a mirror image. Orientation, if you think about it, just means whether or not your object is facing the same way after you're done. The only time it's not is if you do a line reflection. So we're going to begin by doing the triangle ABC as graphed, and I have them written here. And then notice we're going to do 3 parts to our composition, moving right to left. So first we're going to do the reflection over y equals negative x. The line y equals negative x is here if you want to do it graphically. You're counting diagonals. 1, 2, 1, 2 to get for A. B is 1.5, half and 1. And C is also 1.5, so half and 1. Or, as an easier way, you can switch and negate your coordinates and then graph them. Okay, either way, you'll then have a triangle. A prime, B prime, C prime. All right, next we're going to do the reflection in the origin. That means you're counting to the origin. So from A prime, you have to go down 5 and right 1. And if you do that again, you will get the point A double prime, which is now at 1, negative 5. If you notice, what happens is that the coordinates are just negating. So this one will become 5, negative 2. This one will become 4, negative 7. If you want to continue counting, you can. B prime would go right 5, down 2. So 1, 2, 3, 4, 5, down 2. Same thing for C. You'd go right 4 and down 7. So right 2, 3, 4, and down 7. And then the final one will be the translation, which is 2, 7, which means right 2, up 7. So you can graph that and count them from A double prime, right 2, and up 2, 3, 4, 5, 6, 7. Or you can do the shortcut by adding 2 to your x value and 7 to your y. Add 2 to the x and 7 to the y. Add 2 to the x and 7 to the y. So whether you count or graph, either way, you should get the same coordinates. Okay, and then if you look, part C says, which of the following does not preserve orientation? It's a reflection in a line. A line reflection is the only time you're going to get a mirror image, and so it would be that one. All right, finally, number 13. We have 2 points, 3, 0, and negative 4, 6. And we're going to perform a few different transformations to each one. The first one, we're going to write the images of the points A and B after a reflection in the line y equals x. If you can remember, that means that you would just switch your coordinates. So A would become 0, 3, and B would become 6, negative 4. For part B, we're going to also do the images of A and B. So we are not going to use A prime and B prime to come up with part B. We're going back to the original A and B. It is important to look at what you're doing the image of. Also note that even though this is a positive 90, you need to read the word counterclockwise. Sometimes it will say clockwise or counterclockwise, and you must follow the word. So if we're doing this on the graph and rotating it, you're going to go counterclockwise 90, and you'll see A is at 0, 3, and B is at negative 6, negative 4. So A double prime would be at 0, 3, and B double prime would be at negative 6, negative 4. And then finally for part C, we're also doing the images of point A and B. So we're going still with point A and B, the originals, and we are reflecting them over the line x equals 2. Remember, that's a vertical line. And so we're counting. A is 1 unit away, so we're going 1 unit away. And that makes A triple prime 1, 0. And then B triple prime, we're going to count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we will be at 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Okay, I will see you in class.